Hello children. Our next chapter is motion in a plane. Chapter 4 from Ncert. We have a quick revision with vectors and scalars. Vectors are those quantities which have specific direction, also have a magnitude, a given magnitude, also can obey vector algebra. All vectors should obey vector algebra. There is an additional algebra for vectors. That algebra has many rules. Vector addition rules, vector subtraction rules, multiplication rules. All these rules vectors should follow. Scalars are those quantities which have a magnitude, may or may not have a specific direction, but they do not obey vector algebra. They obey ordinary algebra. Electric current is a scalar, but it has a specific direction along the length of the wire. But it doesn't obey vector algebra, vector addition rules. Resultant of two currents meeting at any point does not depend on that angle between the two currents. That's why vector property is not assigned to current. Current is a scalar even when it has specific direction. So a vector should have specific direction, specific magnitude. Also it should obey vector algebra. Okay, vectors and scalars. Vectors have specialized rules. A vector can be represented by using a straight line with an arrowhead as per graphical methods. The length of that line gives the relative size of that vector, magnitude of the vector, and the arrow mark shows the direction of that vector. Different types of vectors. Unit vector is that vector which has unit magnitude and a specific direction. Unit vector has its own direction with that of its parent vector. Magnitude of a vector is the size or bigness of that vector. Any given physical quantity may be expressed as a magnitude and its unit, provided with the direction information if it is a vector. For example, velocity is a vector. Velocity of rain falling vertically downward, 12 meter per second. The question is very conventional and is in NCERT. Then wind starts blowing from west to east with a speed of 10 meter per second. So see, this vector needs direction to be specified. A force applied along negative z-axis on an object of mass 10 kilogram. What is its acceleration? See, acceleration, force, momentum, all these quantities are vectors. They need specific direction to be given whenever it is being described. That's a vector. So vectors and scalars. Zero vector has no magnitude and it has a direction, but we do not know. We can not tell what is its orientation. It can have an arbitrary direction. A particle projected vertically upward at the highest point of its path. Its instantaneous velocity vector is a null vector. Null vector is also called a zero vector. But its acceleration is not a null vector. Its velocity is null vector. Acceleration is a constant vector. Body projected upward during the upward course of the journey as well as the downward course of the journey. Acceleration vector is constant in magnitude and direction. A vector is constant only when it is constant in its magnitude as well as in direction. But at the highest point of its trajectory, its velocity vector is zero. A vector, when it is added with an opposite vector or its negative vector, we get a null vector. Sum of a vector and its negative vector gives a null vector. So what is a negative of a vector? A vector when added with another vector gives zero resultant, then that vector is called its negative vector. Equal vectors are those vectors having equal magnitude and same direction. Co-initial vectors are those vectors having same starting point, co-terminus, same final point. Co-planar vectors are those vectors in same plane. Orthogonal unit vectors are those vectors used for representing the directional properties of a given vector along Cartesian sides x, y as well as z. I cap along x-axis, j cap along y-axis, k cap along z-axis. A vector when added with another vector gives another vector. Sum of two vectors is a vector. A vector cannot be added with a scalar. A scalar can be opened. A scalar can be, of course, added with a scalar, but a vector cannot be added with a scalar. But a vector can be multiplied with a scalar. A vector can be divided with a scalar. But a vector can neither be added nor be subtracted with a scalar. Sum of two vectors is also a vector, but product of two vectors need not be a vector. If product of two vectors is a scalar, that product is called dot product or scalar product. If product of two vectors is a vector, that product is called vector product or cross product. So cross product of two vectors is a vector. Dot product of two vectors is a scalar. Work is the dot product of force and displacement. Torque is the cross product of force and distance, perpendicular distance, F. R cross F. Angular momentum is also a result of a cross product. So these all are vector algebra. When you add any two vectors, you have basically two rules. One is called triangular law of vector addition. For getting resultant as per triangular law of vector addition, the vectors which are to be added one another are to be placed successively, consecutively. Tip of one vector should touch with the tail of the other. Tip of one vector touches with the tail of the other, so that both the vectors form an open triangle in same sense. And the third closing side, which closes that triangle in reverse and gives out to be the resultant in magnitude as well as in direction. Second law is parallelogram law of vector addition. Students, those who do not do so, those who are not clear with whatever I'm telling, you can repeat this video and can watch. Don't show any laziness in watching these revision videos, because we already completed this many topics. You may have seen that previous papers also discussed previous important questions based on that concepts. Maximum we are trying to expose. That's why don't miss this. Each of the minutes you have to watch. Okay, not starting and ending. Now, second one is parallelogram law of vector addition. The two vectors to be added are to be held as the adjacent sides of a parallelogram. Then complete that parallelogram, keeping these two vectors to be added as adjacent sides. Then the resultant of that two vectors is the diagonal. Remember, diagonal of that parallelogram drawn from common initial point to common final point. There can be two diagonals. Students may make mistake. The resultant diagonal is that one which is drawn from the common initial point ending up to the common final point. So that is parallelogram. Now, whatever way you add, you get a resultant whose magnitude is unique. Whatever you add, you get the resultant of two vectors has to be unique. What is the resultant of that two vectors? For that, let me make use of the diagram. Let this be the first vector. Let this be the second vector. Let me add these two vectors by using parallelogram law of vector addition. For that, I take the photostat of this one. Similarly, I take the photostat of the other one. Now, I have a parallelogram. The resultant of these two vectors, vector A and vector B, is the diagonal drawn from the common initial point to the common terminal point. Let it be vector A plus vector B in magnitude and resultant. Maybe the name. Okay, the angle between the two vectors. When vector A is extended, you get angle theta. Resultant makes an angle alpha with first vector. Drop a perpendicular from tip of second vector onto the line of first vector. So that this angle is 90. Then this angle made by the resultant with the second vector B, that is the second vector B, is beta. Then from this small right triangle, adjacent side is B cos theta, opposite side is B sin theta. Then from this big right triangle whose resultant is modulus of A plus B, modulus of A plus B, which is modulus of R, equal to this big right triangle. You can use Pythagoras theorem and you may get A square plus B square plus 2AB cos theta within full square root. Okay, and also if modulus of vector is equal to modulus of vector B, if modulus of these two vectors are same but they are different directions, then you can use this formula for getting the modulus of their sum. Modulus of A plus B is equal to, you can use this as a shortcut, 2A cos theta by 2. If that angle theta is 0, you get 2A. If that angle is 60, you get root 3 times A. If that angle is 120, you get A itself. If that angle is 180, you get 0 resultant. So that is very important. If modulus of these two vectors to be added are same, then sum of the two vectors having modulus 2A cos theta by 2. Okay, then what should be the direction of that vector, for which we need to define alpha for that? Tan alpha, one of the way, tangent law, tan alpha equal to B sin theta, opposite side divided by adjacent side, A plus B cos theta. Tan alpha equal to B sin theta by A plus B cos theta. Also, you can drop one more perpendicular from tip of first vector onto the resultant, keeping this angle 90 degree. Okay, then let this be O, this be P, this point be M. Okay, let this point be Q, let this be N. Then this PM can be written as A sin alpha, can be also written as B sin beta, leading to law of sines. Similarly, this side Qn can be expressed as B sin theta, also can be written as R sin alpha. That is R sin alpha equal to B sin theta. B sin theta and R sin alpha are same Qn. Solving these two we used to write. Watch, that is very important result. The way by which we arrive at the conclusion is also important. The result will be written very easily. You write any side A divided by sine of the angle between the other two. One side is A. Angle between A and B is what? Angle between A and B is theta. So any side divided by sine of the angle between the other two. What is the angle between B and R? There are three vectors A, B and R. Angle between B and R is beta. So A by sine beta is B divided by sine of the angle between the other two. Other two are A and R. Angle is alpha. Equal to R divided by sine of the angle between the other two is a constant. Whatever number of vectors, you can follow the same method, whatever name we assign to. So this is called law of sines. The first one is called law of cosines. The middle one can be used as a shortcut if moduli are same. Angle theta moduli same, angle theta 60, root 3 times. Theta 90, root 2 times. Theta 180, 0. Theta 0, resultant 2a. So that method is very much useful. So that's mostly I have told you all the things whatever required for a competitive examination regarding vector addition. So vector addition, basically there are two rules between two vectors. Okay, more than two vectors are there, we can use polygon law of vector addition, keeping the vectors to be added as the adjacent sides, consecutive sides of an open polygon, and the resultant is the last side which used to close that open polygon in reverse sense. That will give you the resultant, and that is called polygon law of vector addition. Any number of vectors forming a closed loop gives you zero resultant. Any number of vectors forming a closed loop give you zero resultant. Okay. Now we have learned parallelogram law. Similarly, you can follow the triangular law of vector addition also. Vector addition has got basic properties. A vector can be added with a vector, can be subtracted with a vector, giving another vector. Vector cannot be added with a scalar. A vector, when added with its negative vector, gives zero vector. A vector, when added with a zero vector, gives that vector itself. Okay. Then a unit vector can be expressed as that vector divided by modulus of that vector. So that vector can be expressed as modulus of that vector into a cap. Okay, how to find a vector and its component along any axis? Suppose this is the x-axis. I want to get the component of vector A along x-axis. For that, for getting component of any vector onto any other axis, you drop a perpendicular from the tip of that vector onto that axis where you need to get the component. Then measure the adjacent side. That adjacent side can be measured as a cos theta, as theta is that. Then component of vector A onto vector x is a cos theta I cap, because the unit vector along x-axis is I cap. This is one of the applications. A cos theta I cap is the component of vector A along x-axis. This is one of the applications of this concept of unit vector. Unit vector has magnitude 1. So whatever vector is unit vector, for checking, you check the magnitude of that unit vector. If it is 1, that will be a unit vector. For example, if a vector is given as vector A is equal to I by root 2 plus j by root 2. What do you say? Is it a unit vector or not? You try to find out its resultant. Resultant by using Pythagoras theorem. As these two vectors are at 90 degree, you can use Pythagoras theorem. Root of 1 by root 2 whole square plus 1 by root 2 whole square, that is equal to 1 by root 2 whole square is 1 by 2. That is 1 by 2 plus 1 by 2 equal to what? 1. Root 1 is equal to 1, so it should be a unit vector. So I by root 2 minus I by root 2 also, I by root 2 minus j by root 2 also is a unit vector. So unit vector has unit magnitude. For checking, you find out magnitude. Then if it is 1, that is a unit vector. Okay. Similarly, vector subtraction is also there. To subtract any vector from other vector, you just add the reciprocal. For example, if vector A minus vector B can be redefined as vector A plus negative vector of B, then how to draw it graphically? First vector A, as we have drawn second vector B, first vector namely vector A, second vector namely vector B. What is the negative vector of vector B? Let us try drawing negative vector of vector B. Negative vector is of equal magnitude and opposite direction, and that is minus vector B. Draw the third closing side from the tail of the first vector onto the tip of the second vector, and that will measure you vector A minus vector B. Already we have measured vector A plus vector B along this line. So this is vector A and vector B, vector A plus vector B, and this is vector A minus vector B. Also, this is a very popular question. If these two vector A plus B and vector A minus B are of equal magnitude, vector A plus B and vector A minus B are of equal magnitude, what is the angle between the two? And that we can substitute vector A plus B equal to vector A minus C, A minus B, vector A plus B equal to vector A minus vector B. You can try to find out the answer. A plus B equal to A minus B, you equate and you can try the answer. What is the modulus of A minus? Modulus of A minus B equal to square root of A square still plus B square but minus 2AB cos theta. If modulus of vector A equal to modulus of vector B, therefore modulus of their difference is equal to formula, shortcut formula 2A. It's not cos theta by 2 but 2A sin theta by 2. Okay, as I said earlier, you can try here. If theta is equal to 60, you get answer A. Theta equal to 120, you get answer root 3A. Theta equal to 0, you get 0. Theta equal to 90, you get 2A into 1 by root 2, that is root 2A. Like this, you can try to answer. So, modulus of the difference of any two vectors, you can use this formula, root of A square plus B square minus 2AB cos theta. So, vector algebra, vector addition and vector subtraction we have finished. See, you can see the textbook also. Textbook wise, let us move. Scalars and vectors. Vectors, position vector, displacement vector, all that important. But the chance of asking a question directly is very rare. Position vector used for representing the position, it has a fixed initial point. Position vector is a localized vector, it cannot be slided. Position vector cannot be slided, but a free vector is that vector which can be slided. Its origin is unimportant, but position vector has an origin important. Then different types or classes of vectors, all this mentioned here, graphical methods of addition, all that mentioned here. Vector addition properties. Vector addition is commutative. A plus B, vector A plus vector B equals vector B plus vector A. Vector A plus B plus vector C equal to vector A plus vector B plus C. That is called associative law. So vector addition is associative. Null vector, parallelogram law, all this we have discussed. Vector A with 0 vector gives vector A. A scalar product, scalar multiplication with the null vector gives you null vector. 0 multiplied by another vector A is equal to 0 vector. All this important. You just go through the theory also. The quick revision, that's why we have to just slide it and move. Now resolution of vectors. Before that, let us do this problem, very important. Rain falling vertically, speed 35. Wind start blowing after some time with 12 meters per second in east-west direction. Which direction a boy waiting at bus stop should hold umbrella? See the direction. Let me draw it here. Velocity of rain is vertically falling downward. And wind is starting to blow from western side to eastern side. It is eastern side to western side it is mentioned. So east to west. Then what should be, these are the two vectors whose resultant will be the direction in which rain falls. Rain is falling vertically in the absence of wind. In the presence of wind, it should be falling along the resultant. And resultant is along this blue line. So this will be the direction of the raindrops falling. So he should hold his umbrella like this. And this should be that angle theta. He has to incline with respect to the vertical. So that tan theta is equal to what? Tan theta equal to opposite side divided by adjacent side. Opposite side is the velocity of the wind, 12. Adjacent side is vertical, speed of rain, 35. So tan theta 12 by 35. This is the way by which we find out it. Now, resolution of a vector. A vector can have infinite components. Vector can be resolved into any number of vectors. But a given vector can have only two rectangular components in one plane. A vector can have only two rectangular components in one plane. You have a vector like this. For resolution of that vector into two rectangular components, you choose our coordinate system. So this is x-axis and this is y-axis. Vector A is that vector. Let this be the angle theta. Drop a perpendicular from tip of that vector onto both this axis. Then this measures a cos theta I cap and this measures a sin theta j cap. Let a cos theta I cap be ax and a sin theta j cap be ay. So vector A can be resolved as ax I cap plus ay j cap. Here ax I cap is called a cos theta I cap. Ay j cap is called a sin theta j cap. Ax I cap is its x component and ay j cap is its y component. Component of a vector is a vector. Component of a vector is a vector. This is the way. In this way we can resolve that vector into 3 dimensions also. Okay. Then if it is resolved into 3 dimensions, vector A can be written as A cos alpha I cap plus A cos beta j cap plus A cos gamma k cap. All can be only expressed in terms of this direction cosines. Okay. Next. So rectangular components of a vector is very important. That vector can be written as ax I cap plus ay j cap. Now, the applications of this vector addition. Application of vector addition is going to be the important one. It's a part of revision. Let us do that. That is discussed in the topic projectiles. So we apply whatever we have learned here in projectiles. Rest of the topics are appearing in kinematics. Rest of the topics appearing in kinematics. Because this one, two-dimensional motion is motion in a plane. Motion in a plane can be regarded as superposition of two independent one-dimensional motions. So already we have done that velocity of an object moving in a straight line can be expressed as v is equal to u plus at for constantly accelerated motion. Okay, simultaneously that body may have velocity along y-axis. Then you make use of two independent relations like v equal to u plus at with x and y suffixes. For example, vx is equal to ux plus axt, vy equal to uy plus ayt, two independent equations, and solve that two equations to solve the problem on planar motion. Motion in a plane can be regarded as superposition of two independent one-dimensional motions along mutually perpendicular directions. Now relative velocity in 2 dimension also in the same procedure. We apply all this what we have learned in the topic projectiles. Projectiles. Any body thrown in air which is only acted upon by gravitational force. No other forces, only the force acting is gravitational force. Which describes a parabolic path. At no point during its trajectory, the value of acceleration due to gravity changes because the value of g should be constant. Also, the curvature of Earth should be neglected for this projectile. And this will be the path of that projectile. This is y axis and this is x axis. Different equations used here. Formula for maximum height during the flight. Formula for range R. Formula for time of flight at origin 0, 0 projected. Horizontal distances are vertical distance at the point of striking is 0. Then at this point the time of flight is defined as t. U is the initial speed of projection. Angle theta is the initial angle of projection made with horizontal. Then formula for maximum height, H maximum, capital H, is equal to U square sine square theta divided by 2g, or may be written as Uy square by 2g, where Uy is the initial vertical component of velocity. Similarly, flight time, time of flight, time for which that object is in air, for motion under gravity, that is 2u sine theta divided by g, that can be short formed as 2uy by g. Now horizontal range, third equation, r is equal to horizontal distance over the same plane, same line. R is equal to u square sine 2 theta divided by g, can be shortcut form 2ux uy divided by g. And shortcut forms are also important. See, a vector whose initial velocity may be written as 3i plus 4j. Let us practice this. 3i plus 4j meter per second. What is the horizontal component of velocity, initial velocity, which is 3, which is a constant? A projectile has horizontal component constant. What is its vertical initial component? That is 4. That is not a constant. Horizontal component remains constant. Vertical component of velocity at each instant of motion is variable. Vertical component first decreases, becomes 0 at the highest point, then increases at the same line, at the same plane, it becomes again same numerically. For example, initial vertical component is plus 4. We choose Cartesian convention, upward direction positive. Vertically upward direction positive, downward direction negative. So initial vertical velocity plus 4, final vertical velocity minus 4. What is the final velocity? Minus 4 j cap. Initial velocity vertical plus 4 j cap. What is the change in velocity vertically? Minus 4 final, minus plus 4 initial. Minus 4 minus 4 minus 8. Change in velocity minus 8. What is the change in velocity along x-axis? 0, because initially as well as finally change in velocity 0, initially finally velocity same. Initial velocity of projection 3i plus 4j. Final velocity where it hits the ground is 3i minus 4j. How to find the time of flight here? Time of flight is equal to 2uy by g. Uy is 4. 2 into 4 by 10. 0.8 seconds. What is the maximum height of this projectile? Uy square by 2g. Uy is 4. Uy square is 16. 16 divided by 20. 16 by 2 is 8. 8 by 10 is 0.8. Again, range 2ux uy by g. So product ux into uy, 3 into 4, 12. 12 into 2, 24. 24 by 10, 2.4. What is the angle of projection? Angle of projection is tan theta is equal to opposite by adjacent 4 by 3. Tan theta 4 by 3, then theta is equal to 53 degree. So angle of projection made with the horizontal 53 degree. Initial velocity makes an angle 53 degree with the horizontal. That is the projectile. Okay, like this many results can be inferred from a single data given. That's the advantage of being a vector. Okay, so these vector expressions are very important in getting the answers. Now, equation of a projectile. Path of projectile is a parabola. At an instant of time, let this be here somewhere. At this point, its x coordinate is x, y coordinate is y. The projectile is at the point P, started from the point O origin. It reaches P in time small t seconds. X coordinate x, y coordinate y. Then what is the equation of that projectile? Y is equal to x tan theta minus g x square divided by 2 u square cos square theta. Also can be shortcut form. X tan theta can be taken as a common factor into 1 minus, this can be rewritten as x by r. X tan theta into 1 minus x by r. Okay. In last 2022 mains paper, a question was asked that y is equal to 5 into 1 minus x. This is the equation of a projectile. 5 into 5x into 1 minus x. 5x into 1 minus x. How it can be written? 5x means x tan theta. So tan theta equal to 5, theta equal to tan inverse 5. And 1 minus x by r, when you compare, range is equal to 1. Range is 1 meter. Like that we can easily guess the answer. So this pattern also is important. 5x into 1 minus x. Format also question may be asked. For that you by heart shortcut x tan theta into 1 minus x by r. X tan theta minus gx square by 2u square cos square theta. Okay, one more formula. R tan theta, connection between range and height. R tan theta equal to 4h by heart. One more. R tan theta is equal to 1 by 2 gt square. So range, angle, time of flight relation. Now capital H is equal to 1 by 8 gt square. Capital H is equal to 1 by 8 gt square. Height 1 by 8 gt square. Relation between maximum height of flight and flight time. Flight time is the time over which the body lies in air. For what time a body lies in air? That is the flight time. All these equations are relevant there. At the highest point, a projectile at its highest point. What are the features at highest point? It's a unique point. At highest point, its trajectory. At this point, m. Horizontal velocity is what? U cos theta. So, horizontal velocity at the highest point may be written as velocity along x-axis. But velocity along y-axis, that instant 0. Angle made by velocity with horizontal is 0, theta 0, Vy 0, Vx equal to u cos theta. X distance is equal to range half, r by 2. That is symmetrically dividing into 2. So that distance is half the range, r by 2. At that moment only, acceleration becomes perpendicular to velocity. Angle between acceleration and velocity becomes 0. Acceleration perpendicular to velocity. Highest point, acceleration perpendicular to velocity is the one and only point where acceleration perpendicular to velocity. As the object moves up, angle between acceleration and velocity, what happens? Initially, angle between acceleration and velocity is obtuse. Angle reduces, becomes 90. Then finally, also it reduces. Here, it becomes acute. Angle between acceleration and velocity continuously reduces. Angle between acceleration and velocity continuously reduces. And at the highest point, it becomes 90 degree. X component of velocity is a constant. Angular momentum at the highest point. Angular momentum at the highest point. About O. Angular momentum of the projected particle at the highest point about O is equal to linear momentum into perpendicular distance. Linear momentum is mu cos theta. Perpendicular distance is what? What is the perpendicular distance? That is h max. H max. You can substitute for h and get into the answer. What is the linear momentum at the highest point? Mu cos theta. What is the kinetic energy at the highest point? That is mg capital H. That is mg into capital H is u square sin square theta by 2g. That is half m u square. G gets cancelled. into sine square theta, where half mu square is the initial kinetic energy. So at the highest point, kinetic energy becomes half mu square sine square theta. Half mu square is the initial kinetic energy. So K divided by K0 is half mu square, is equal to sine square theta. So what fraction of kinetic energy has reduced? Kinetic energy has become sine square theta. That's important. That type of questions are very important. So sine theta equal to root of K by K0. Sine theta equal to root of K by K0. For example, if kinetic energy of a projectile at the highest point of trajectory is 1 by 2, 50%, then this becomes 1 by 2 sine square theta 1 by 2 sine theta 1 by root 2 theta 45. Angle of projection is 45. Last year 2022 mains paper this question was asked. So kinetic energy equal to K0 sine square theta, then potential energy equal to K0 cos square theta. Okay, total energy is a constant. Kinetic energy plus potential energy. So highest point of trajectory, many things are to be noted. These are all about the projectile called oblique projectile. Also you can discuss regarding the instantaneous velocities at different points. An object is projected at an angle theta with the horizontal, that velocity vector is u, y axis, and this is x axis. Path of projectile is a parabola as seen by a person on ground, but as seen by a person from other projectile is a straight line. Path of a projectile as seen from other projectile is a straight line. Path of a projectile as seen from ground, fixed ground, is a parabola. At another point, how to find out the resultant velocity? For that we find vertical as well as horizontal components separately. Horizontal component Vx, vertical component Vy. Vx is equal to Ux equal to u cos theta. That's a constant. Horizontal component does not change. But Vy equal to, you can use the kinematic equations either Uy plus Ayt. Here anyway, Uy is u sin theta. U sin theta, and Ay is minus g. T is the time after which it reaches there. Or you can use the other kinematic equations also, whichever is relevant. Now Vx and Vy are available, then V is equal to square root of Vx square plus Vy square. Square root of Vx square plus Vy square. Okay. Equation of a projectile may be expressed as y equal to ax plus bx square. This is the pattern. Ax plus bx square, which can be compared with x tan theta. This we have written earlier, you may remember. X tan theta minus gx square by 2u square cos square theta. X tan theta equal to, y equal to x tan theta minus g x square by 2u square cos square theta. Here you can compare. Tan theta equal to a, so theta tan inverse a, and that constant b is equal to g divided by 2u square cos square theta, from which you can find out u cos theta. U cos theta is ux. U cos theta equal to g divided by 2b within square root. So u cos theta equal to g by 2b within square root. All these are very important. Repeating, y is equal to what? Y is equal to ax plus bx square. You take the first derivative. dy by dx is equal to a plus 2bx. At the highest point, of the trajectory, at the highest point of the trajectory, at this point m, this is y and this is x. The slope will be 0. dy by dx is the slope of yx graph. Yx graph is a parabola. dy by dx is the slope of that ys graph. At the highest point, slope is 0. So at highest point, dy by dx is equal to 0. That is why a equal to minus 2bx. So x is equal to minus a by 2b. So modulus of x is equal to a by 2b. Then x will be half the range. And this will be x where total range will be 2x. So what is the range? Range is equal to 2x. That is a by b. Then range is equal to a by b. You can easily get range as ratios. A by b, not b by a. Okay, like this you can get into results. These all are previous questions. This is asked in 2020. Range a by b. You can find out the maximum height also. From this, u cos theta already we know. Then you can find out u sin theta and u square sin square theta by 2g. You can find out the maximum height, time of flight, everything you can have from a single result. So that equation of projectile based questions are also important. So projectile motion is a motion in a plane. Mainly there are three. Vertical projection, already we have done in kinematics. Straight line. Now oblique projection, we have completed. Now one more, horizontal projection. The body is projected horizontally from top of a tower. Body projected horizontally from top of a tower. Body projected horizontally from top of a tower, like this. With a speed u, path of projectile is parabola. Height is h, range is r. Then, the speed of projection is u. Time after which it reaches ground, capital T, is equal to square root of 2h by g. Same time as if it was falling freely downward vertically without any velocity. If that body was dropped at the point also, it would have fallen down with same time. It is projected horizontally, it doesn't make any difference, it falls down with same time. But range is equal to horizontal velocity into time of flight. R is equal to horizontal velocity into root of 2h by g. So ratio of range is as ratio of speeds. Because whatever speed you choose to throw horizontally, range does not change. Time does not change, but range changes. Range bears the ratio of speeds. If ratio of speed is 1:2, ratio of time is 1:1, ratio of range is 1:2. If ratio of speed is repeating, ratio of speed is 3:5, ratio of range is 3:5, but ratio of time is 1:1. Appo speed in the ratio thanneyaanu range in the ratio. But time in the ratio 1:1. Time does not depend on the speed of projection. Same formula root 2h by g. Time maaranamengil height maaranam. Horizontal projectile. At any instant you can find out the velocity also. The tangent is v. Horizontal is vx. Vertical is vy. You can treat this planar motion as the combination of two independent one-dimensional motions. You can treat horizontal one-dimensional and vertical one-dimensional motion, combine, solve, then solve the problem. Okay, that is all about horizontal projection. All projectiles, other forces other than gravity neglected. Of course, there is air resistance. The presence of air resistance reduces the flight time in the next half. That is, time to descent will be more. Changes. Time to descent is more than time to ascent because of air resistance. Time of ascent is u sin theta by g. Then time of descent will be greater than u sin theta by g when you divide this total time. Total time of flight is time of ascent plus time of descent. Due to symmetry, as air resistance is neglected, total time equally divided. So u sin theta by g is the time of ascent. U sin theta by g is the time of descent. Okay. Now, for this quick revision, we only left with one more topic, that's circular motion. In this chapter, we have to conclude with the Circular motion. Circular motion. We have only uniform circular motion. Uniform circular motion is periodic, repeated after regular intervals of time. Uniform circular motion is periodic. Every periodic motion gets repeated after regular intervals. Periodic time is the time after which it is getting repeated regularly. Frequency is the number of rotations in 1 second. Reciprocal of frequency is called time period and vice versa. The relevant formula there. Angular frequency omega is equal to 2 pi by t. Another one. Omega equal to 2 pi f, where f is the frequency. Omega equal to v by r, where v is the linear speed and r is its radius. V equals r omega. All these equations are important. Omega can also be written as 2 pi nu. Okay, I have already written 2 pi nu. Omega can also be written as d theta by dt, where d theta is a small angle, dt is the time required for that angular displacement. Angular displacement by time. Unit will be radian per second. Unit is radian per second. In uniform circular motion, what are constants? In uniform circular motion, what are constants? First one, speed. Second one, kinetic energy. Third one, time period. Time period is a constant. Fourth one, frequency. So speed, kinetic energy, time period, frequency, angular momentum. All these are constants. Angular momentum is also constant. But what are variable? Force variable, velocity variable, acceleration variable. So momentum variable. Momentum, force, velocity, acceleration, all these are variables. So average acceleration over one cycle is 0. Average momentum value over one circle is 0. Average velocity over one circle 0. Average force over one circle 0. The force is called the centripetal force. Centripetal force is that component of force which only used for changing the direction. Centripetal force is always perpendicular to the velocity vector. If there is a component of force which is always perpendicular to linear velocity vector, that force does not make any change in the speed of that object. Instead, it changes the direction. And that component of the force which makes the changes in direction continuously without making any change in speed is called centripetal force. Centripetal force is an agency like friction, gravitation, tension, normal component of force. Different agencies behave as centripetal force. It's not a real force. It can be some of the agencies, external agencies can act as this role of centripetal force. So centripetal force does not make any change in speed. So centripetal force does not make any change in kinetic energy. So work done by centripetal force is 0. Work done by centripetal force is 0. Centripetal force is always acting towards the center. Centripetal acceleration or radial acceleration is measured as v square by r. Also can be measured in terms of angular speed, omega square r. Direction of centripetal acceleration is towards center. V square by r. So v equal to root a r, omega equal to root of a by r. All these equations are important. Here, speed does not change. When speed changes in a circular motion, that is non-uniform circular motion. In non-uniform circular motion, resultant acceleration can be resolved into two. One is tangential and the other is radial. The radial component is called the centripetal one. The other one which makes change in speed is called tangential acceleration. Okay, that is not in this chapter syllabus. We have only uniform circular motion. Then the formula for centripetal acceleration is v square by r. or A is equal to omega square R. Omega can be 2 pi by T. All these equations are important. Okay, A equal to omega square R, A equal to 2 pi by T whole square R. Omega can be written as 2 pi F. So 2 pi F whole square into R, all these equations are worth noted. Maybe asked. So centripetal acceleration can be measured as speed square divided by radius. Let us apply this. In the case of a projectile, this was a previous mains question paper question. An object is projected at an angle theta with horizontal with a speed v0 at the point O. We know at every point the radius changes during the path of projectile because it is a parabola. What is the radius of curvature at the point of projection? Radius of curvature at the point of projection is equal to v square divided by component of A perpendicular to the velocity. So velocity vector is this. So what is the component of acceleration perpendicular to velocity? Here, acceleration due to gravity is along vertically downward. Component of acceleration due to gravity along a line perpendicular to the initial velocity vector can be measured by dropping a perpendicular from tip of that acceleration vector onto that line. And as this angle is the angle of projection theta, angle between perpendiculars is also same, so this angle should be theta. Angle between perpendiculars is same. That's why that angle is also theta. Then this one is acceleration due to gravity, so this should be g sin theta. So the radius of curvature at the point of projection can be expressed as v0 square, speed square divided by component of acceleration along that direction. What is that component along that direction? Component of acceleration perpendicular to velocity, that is not g sin theta, g cos theta. We need this adjacent side, not opposite side. That is v square divided by g cos theta is the radius of curvature at the initial point of projection. V square by A. This is one of the applications of that formula. Here speed is not a constant, but the component of acceleration which makes the changes in direction only we can identify by using this formula. Component of acceleration making change of direction will be perpendicular to the velocity vector. The component of acceleration parallel to the velocity vector here is g sin theta, and g sin theta is the reason why the speed reduces. At what rate the speed reduces? Is the rate at which the speed reduces is g sin theta, that is acting against v0, that's why it reduces. G cos theta doesn't have any connection with the change in speed. It has only function to change the direction. So radius of curvature v0 square by g cos theta. That's uniform circular motion. In uniform circular motion, speed constant, repeat, kinetic energy constant, time period constant, frequency constant, angular momentum constant, all these constants. But force, velocity, variable, momentum, vector, variable, direction changes. Force, magnitude does not change. Acceleration, magnitude does not change, only direction changes. That's circular motion. More details about circular motion we'll be doing in chapter rotational dynamics. Okay, we'll move on with that chapter, projectiles. Path of a projectile is parabola. Equation of path of projectile, all that we have discussed. Horizontal range, maximum height, flight time, Galileo's observation in his book Two New Sciences stated for elevations which exceed or fall short of 45 degree by equal amounts, ranges are equal. Let me exemplify. We have a coordinate system from the origin An object is projected at an angle theta. Suppose this is the angle bisector and that angle is 45 degree. You have another projection at an angle alpha. You have one more projection this also will be alpha. Then this angle of projection, you see, this angle of projection is 45 plus alpha. Minus alpha. And this big angle of projection is 45 plus alpha. And there are two throws, throw number 1 and throw number 2. Both with same speed. Care should be taken, the speed should be same. So the reference is the 45 degree. 45 degrees is the reference. Then the two throws will have same range. The two throws will have same range. That means you have a given projection. You have a given projection which gives maximum range. Range maximum when angle is 45 degree. For getting maximum horizontal range, you have to throw at 45 degree and R max is equal to U square by G. U square sine 2 theta by G. 2 theta becomes 90. So sine 2 theta, sine 90 becomes 1. So it becomes U square by G, that is R max. R max equal to U square by G. Now alpha may be 1 degree, 2 degree, 10 degree, 20 degree, whatever. So that 45 plus alpha is one of that angles, plus 45 minus alpha, the other angle. Let first be theta 1, next be theta 2. What is the sum? That is equal to 90. That means sum of these two angles of projection should be 90. That is, if one is theta, then the other is 90 minus theta. That if one is theta, other is its complementary angle. So complementary angles of projection with the same speed gives out the same range. Ranges are also equal. But at an angle 45 degree, it gives maximum range. Other two throws will give a reduced range, but that ranges are same. These two throws will give out same range for first throw and second throw. The first throw R1 and second throw R2 ranges are same, but still less than R max. For R max, it should be 45 degree. Okay, that's the thing. So for complementary angles of projection, let us do that. Theta 1 is equal to theta 2 equal to 90 minus theta. What is the ratio of ranges? R1 by R2 is 1 by 1. Similarly, ratio of flight times, you can try to substitute. You may remember the result, tan theta, h1 by h2. By maximum results are to be by Herted, tan square theta. R1 by R2, 1 is to 1. T1 by T2, tan theta. H1 by H2, tan square theta. Okay, now T1, T2 products 2 times range by G, 2R by G is also important. Then range R is equal to half G T1, T2. Range R is equal to G T1, T2 by 2 or half G T1, T2 or range R is equal to half G can be approximated to be 5. 5 T1, T2. So maybe mains question, R is equal to X T1, T2 where X is. For complementary angles only. T1 and T2 are not equal, different. Okay, which time will be less? When angle is less, time is less because sine function, time depends on sine function. Sine theta less, suppose theta 1 30, theta 2 60. So for 30 degree time is less, 60 degree time is more. Okay, but their ranges are same. Angles are different, some 30 plus 60, 90. Like that you can conclude. That is all observed by Galileo for the first time, called Galileo's observations. So these equations are very important. So T1 by T2 tan theta, H1 by H2 tan square theta. Okay. with that, we have completed the revision. Now, maximum height, all this text wise also you have to go through this very well. Read all this very well. These all questions you can easily solve. Uniform circular motion also we have completed. Different formula we have used. Okay. Don't forget to see the summary as well as points to ponder. With that, we have finished the quick revision of chapter vectors, motion in a plane, chapter 4. Okay, soon we'll be meeting with next chapter, laws of motion. Thank you.